Hello, today I will show you how to connect Houdini to FL Studio and create a real-time effects like this. I can play like manually on keyboard and it's responding in real time. Project files are available and free on Gumroad. Firstly, you need a program called Loop MIDI. We will create custom port. Let's call it Houdini FL Connect. Done. Now open FL Studio. I have prepared a pattern here. Now go to Options, MIDI Settings. You'll find here port that we've created in Loop MIDI and assign it a port 1, for example. Okay. Now we need a patcher. This one will be working to transfer data to that Loop MIDI. We have output node. Right click it, input events and MIDI port 1 as we assign it to port 1. Drag that green dot or green dot. And if I cut that pattern and paste it here, and we won't hear anything because it's not an instrument, but you can see in Loop MIDI that some information I'm going through. So it means that information are connected to that Loop MIDI. But I wanna hear something, so in Patcher I will add flex and just quick instrument here, with block. Here. So everything is set up for FL Studio at least. Now let's read that information in Houdini. Okay, we are in Houdini, and firstly we need chop network. Dive inside, and there is node called MIDI in. Here are some settings, but we need MIDI source. If you can't see the right name, Houdini FL Connect, in my case, you need to reload Houdini. Let's do that. Okay, I've reopened the program, and now in MIDI source I can see my Houdini FL Connect. Let's just make FL Studio to play constantly, but I don't wanna hear anything, so I know that it's playing. But nothing happened. You need to check this, echo messages to text port. Nothing is happening. That's because we need to set up things. Firstly, go to that node tab, and we need to specify which nodes need to be read. In my case, I have highest node is A#7. The number of this node 94. You can see it here. If I hover over the node, you can see that it's 94. For the lowest node, I have these, and if I hover it, it's 34. We need to specify that. So we have 34 to 94. So this MIDI in will read notes in that region. And now if I play, and go to Motion Effects View, you'll see that notes are being pressed. So note 94, 93, 81, 43. So we know that it's reading. Also, you can notice that we are in channel 1, so we can just put it here. We don't need any channels. And yeah, if I play, you'll see that notes are being pressed. You can disable echo messages. In time where note is pressed, it became 1. So yeah, Houdini is reading our notes. Now let's run through the setup I have. So it's constantly playing. Default MIDI in, you can delete channel prefix, you can remove that controller, we don't need it, and let's go through what I have here. Now, the first thing I need is to get amount of channels. In my case, there are 61 channels, and I need that information to get the right amount of keys. So what I did, we are going to WOP chop. It's really simple. Just grabbing that total number of channels and put it here to value. And now every channel is on the value of 61. After that, I deleted everything except first channel, rename it to NC, and it will work to us a little later. So we have amount of channels, 61. And for now, let's ignore those two nodes, just raw output from the MIDI without any processing. Geo setup, I'm adding a point, then I need to copy that are corresponding to the number of keys that are in our range. I'm using copy and transform. And how do we use the node that are storing the value of amount of points? So this one, copy it. And here in the total number, I'm writing the next expression, chop. And in the puts, I'm pasting that path to that null. And also I need to specify the name of the channel. So it will be NC. And now it's reading that value from that null. And it's 61 NC. So I'm having 61 point, and this is the range from the lowest node to the highest. After that, I need to read the values from the chops. So after that WOP node, I'm creating the attribute mask. And if I start playing here, you'll see that points are being pressed and lit up with red color. So how to do that? It's all about this chop node. It is get chop channels. So in the path, I'm just sending this out nodes. Then I'm connecting to the channels. So the point, for example, 5 will read the 5th channel, 20 will read the 20th channel, and etc. About samples, we need to have a constant, and there is a bit of math. It's frame -1 because my first frame is 1, but in chops it's 0. And we need to have this constant. It's samples divided by FPS. I will show you where you will get samples. So on this MIDI node, I have a tab channel, and its sample rate are here. I'll just put it FPS. So I'm just copying the parameter and pasting it here. Let's see. It's like paste relative reference. Okay. Then we are multiplying the frame to the sample and converting the float value to int. Samples are integer values. And bind export it to the attribute called mask. Now you see that even it's more clear if I just play here like this. See, corresponding points are being lit up with the red color. Okay. We have that. Now let's set up the basic keyboard. So firstly, I am grouping the black case. So they are like this. Here you can see the code. This offset means that if your note, your base note is not C, you need to offset it to that value. For me, my lowest point is A sharp 2, and C will be 2 notes higher. So I'm putting here -2. Now I'm just adding a bit of scale, P scale, then giving a black case scale, then coloring it, and we'll get back to that gradient later. Then I'm just moving points by this mask. So you'll see the nodes are going under by 3 meters. And if we copy to that points a box, it will look like this. Maybe if I make it gray, it will be more visible. Now we will get back to that record node. Because I want to make this movement of pressed buttons are more smooth, more interesting. Because right now everything happening on the first frame. And if I try to play it, it will be gone because MIDI in are working only on the first frame. So you can see here is dot. And here comes the record node. We will record everything that are being pressed. So for now, if I play, you'll see that every key are being recorded. It's simple to set up, just set record input to the current frame. And now if I open the scene view, sometimes real-time reading values from the FL Studio might get crazy, so you have to go to MIDI in and reset everything. Also in the record, reset channel and resync time. And now if I press play and also press play in the FL Studio, you'll see that we have in real time pressing buttons. And if I go back to the ChopNet and add a little bit of lag, you'll see that smooth moving of the object. So lag is adding a bit of lag, a bit of overshoot. And here comes that the ramp, color ramp. Because our masks are no longer just zeros and one, it's constantly changing. Smoothly. Let's turn sound for a little and see. Now let's work how we can send the data to the CopNet. Firstly, I'm creating, let's get back, dark background. I'm getting that points and copying to them a plane. It's a bit offsetted, so it's like under the case. And here I have a canvas where that effect will appear. So I just agreed with projected UVs and moved it a bit. Oh no, I didn't. Okay. And then I'm transferring the UVs from that grid to the dot planes. It will help us later. After that, I'm adding a connectivity node to have that class attribute. So every primitive is enumerated. I'll tell you why every primitive have to be +1 a little bit later. This node is not needed. And I'm adding a color to each primitive. Let's stop for a bit. It's updating. It's reading attribute class in the range of 0 to n prims. So primitive 0 will have that purple color, and the 16 primitive, so this will have a red one. After that, just multiplying values to be more prominent. Adding null to outplane. Now let's talk about this right side of the setup. You might notice that this stream doesn't have this time dependent icon. So we have this null without any time dependence. And this one do have. And we will get to that later. Now let's dive into cops. The most interesting part. So in the cops we have sub import where we import in our planes that are not time dependent. Then we rasterize it, and we have in this setup and 3 attributes: alpha, CD, and class. As you remember, we projected UVs from the main canvas grid, so they are on their place. And now I need to get back to that example. You can see that they appears only when keys are being played. So that's the whole idea. And somehow we need to feed in the flow solver only those planes that only have been pressed. And I want to show you the problem I faced. Let's now disable this. I faced during that building that setup. We will take that time dependent copy to point. Let's take that time dependent node and delete. And delete the planes that are not pressed. So it's like delete. I'm using group expression to group that attribute mask is lower than 0.1. So everything that is not lit is grouped, and just blast it. Our mask is on the points. Yeah. So now we are getting the planes that are being pressed. So we add in them colors. Let's bring back that connectivity just to have the colors and multiply it by 2. And take that planes. Okay, to the cups. Let's go to the composite view. I forgot that we also need AUVs. So let's get it from our canvas like this. It's a bit messy here. Let's go here. Let's get to cups. So after rasterization, we have in this picture. Now everything is very slow. Sometimes you need to stop and start in FL. And here you can see that maybe even let's go to the chop and reset everything like this. And let's bring our performance monitor. And let's let record. We've seen that our rasterized geo is really time consuming, so it's not doing great in terms of performance. If we go to the cups, we see that these nodes are time dependent, so they are constantly updating. And if I try to make the setup like this, it will be very slow. That's all because of this time dependence. So we don't need that. It's very slow setup. I come up with the idea this UV transfer is also time consuming. Since we are aiming to the real time stuff, it's really necessary to keep things as fast as possible. Let's delete that setup. I mean, let's make it as it was before. We don't need that. So it was like this. So yeah, these nodes are no longer time dependent. So it's like imported and stayed like this forever. What can we do to bring that information about the nodes, about the keys that are pressed? We are getting here. So we have a setup where the planes contains that mask attribute, and we are copy that mask attribute to our main stream of planes grids. So now we have a class attribute that's the same, and also the mask attribute that are time dependent. I'm promoting this attribute from the point to primitive, so it's like this. I am deleting the primitives that are not pressed, so it's like mask attribute is less than 0.0, so it's like mask attribute lesser than 0.1, and just removing that primitive with the points, and we have like this. If we see scene view, there are only planes that are played. If I start playing, you'll see more smoother animation. Let's leave it like that. Then I promote that class attribute that are with deleted primitives. I'm promoted to the detail. So detail stores an array of IDs of primitives that are currently pressed in the current time. And then I'm converting this array of integers to the string attribute. And I will tell you a little later why I do this. The code is pretty simple, I'd say. We just store in that array of integers, declaring the string. And if the length of that array is bigger than 0, then we are converting each item in the array to the string and added it to our declared string, also with the empty space to it. Okay? In case if our length of integers are empty, we are assigning to ID that is not existing, and just creating an attribute called pressed string and assigning that as variable. So you can see we have here array of integers, and here are the string version. Okay, we have that. Why do we need that? And I'll tell you. We are going back to the CapNet, and here are the node that makes the setup works really fast. I'll create it from scratch. ID to mask. So do you remember we have a class attribute that are stored and it represents an ID. So ID to mask is getting that value, and if I put here, for example, 6, I will get the mask for the primitive that has ID of 6 or even 9 and etc. So everyone has a class attribute, and since we have, I can't see, since we have that string attribute with pressed planes, we can use that, feed it here in ID pattern. So we will mask out only those primitives that IDs are coincide in values. So I need to stop. I'm writing the next expression, detail s. It means that this function is designed to return the string value of detail attribute, so we can read that. Why do we need a string? That's because this ID pattern is only accepting the string parameters. Okay, and we are feeding it the path to that null and the name of that string attribute, pressed str. And here you can see, so we are having the animated mask, and the rasterized geo is static. Yeah, we are getting these masks. So and now I can use these masks to multiply it by the color, and I'm getting these colors. Also, I want to get back and say why do I used this not existing ID. That because if there is no k is pressed, it's using 0. So for the 0, we have the background of that image, of that geo. So if you remember, I've added here a class +1, that because if I didn't, then if I try to have 0th ID, I will get that mask, but also the background. I don't want that. So I have to just add 1. And here we are getting that values. Here are our, I'd say, source, but the setup of the flow is pretty simple. I didn't want to spend much time on that flow setup, so it's pretty basic. I have constant, and this is just plain black. To feed it to color, disable it, it will get me an error, so just plain black. Then to the V, I'm feeding a crystal noise, and it also feed it because of oh, you don't get any error. Okay, I didn't know that. So you can use anything here. Oh. For the temperature, I've used alpha value from the rasterized geo and remap it to 0.1, so animation will be more slow. Okay, let's dive into flow. It's already working as expected. So This multiply node that are working by our mask, we are feeding to the pass-through and using that pass-through to add it to our background. Nothing fancy here, and just that animation will have more fall off. I'm adding that bright. If I didn't do that, you will see that our flames are no longer dissolving. So each frame, the brightness of the whole image become 30% less bright. I'm not sure that I understand how it works exactly, but I use that to follow things. So yeah, I'm having a crystal noise, splitting it to get that green channel that are moving things upward, inverting it, and join it with the zeroed out red and blue channels. And if you plug it to the V, it will go up like this. And I'm just importing that canvas, that plane, to the preview material. Get to the scene view using that cop net and also moving it a little bit down. And here you have it, animation, the result I wanted to show you. I forgot about this performance monitor and it causes freezing stuff. And here you have it, 30 FPS, even though we can use substeps like 4. Yeah, even with 4 substeps it's working. This simulation are more detailed.